Hi, everyone. My name is Tamara, and I will be your host tonight. Welcome to 13th InterVenture Webinar. We are a Swiss company that builds tailor-made distributed teams for our partners. We like to say that we're engineering fuel for your visions. We have our own team model, which is 100% dedicated team service designed for long-term product development purposes. And we have a managed freelancing service designed to address your temporary engineering workload that do not require you to hire permanent team members. Tonight, we will talk about infrastructure as code. Our guest is Petar Marinkovic, who is Senior DevOps Engineer at Redbox, our long-term partner from USA, which builds a streaming service that offers both live and on-demand content via their website and apps. Their remote team in Belgrade currently counts 37 employees. Petar has more than 14 years of experience in IT. He worked in many different fields, such as software development, public sector, finance, both in Serbia and Germany. He started to play around with cloud and AWS in 2012 and Google Cloud Platform in 2018. He is active holder of many popular certifications such as AWS Certified Solution Architect, Professional, and GCP Associate Cloud Engineer. If you have any questions, Petar will answer them at the end of his presentation. You can use chat or Q&A option at the bottom of your screen, or we can turn your audio so you can talk to Petar live. Just drop me a message in chat box. Recording of this webinar, as I said, will be available on our YouTube channel from tomorrow. I will post the link in chat box to our webinar playlist where you might find something interesting for you. Welcome again, all of you, and welcome, Petar. The floor is yours.
Okay, thank you. So I will be sharing my screen now. Okay, and let's start with the presentation. So, as Tamara said, our today's topic is infrastructure as code. So this is a very vast topic, and I would say that this is probably one of the pillars of the DevOps methodology. And even though, like, if your companies have or have not DevOps engineers and dedicated DevOps teams, or no matter if you know a DevOps engineer or even a software developer, so I would say that this is something which is a must for any company today in 2021. And also I would say it's not only tied to the DevOps, but also to anyone today using the cloud or any similar to cloud service. So here is today, like in short, what we're going to speak about. So I will first, of course, introduce myself a little bit. We will also cover the topics of what is infrastructure as a code, how it works in practice, best practices and benefits, how to pick infrastructure as a code tool for your company, some horror stories from my experience, but maybe also from the experience of some other people that I know. I mean, I need to say this because my boss is listening to this, so those are not my examples. I never did anything wrong. It's all the people I know. And we will conclude with some Q&A. So a little bit about myself. So as Tamara said, I started to work in IT really early in 2006. So it was almost 14 years ago. And I started, as many of the DevOps engineers today, I think that there are only two paths on how to start and how to be a DevOps. One is through the infrastructure, system, network administration. The other part or the other role is through the software development. And as part is from my education background, I have the Bachelor of Computer Science here from the Computer Science University here in Belgrade. And I also have an MBA degree from Kočuli Business School. In my career, as I said, I started 2006 in Serbia, in Belgrade. I spent a couple of years abroad in Germany, where I worked for the German stock market with the Deutsche Börse Group. And I got back to Serbia in 2018. Then from 2018, I'm the part of InterVenture, with first starting with GoGo Air, and then later on from 2018 as a part of the Redbox LLC, our US partner. As Tamara said, working with AWS from early 2012, working with GCP from 2019. Here are a couple of logos of the company that I worked for from all the different industries. And for those that were, I would say, kind of connected or were following the US elections, yes, I worked for Dominion voting that was pretty popular last November about all the stories of what's happening in the US election. But I was working for them until 2015, so I really cannot comment on the latest proceedings, but you're more than welcome to ask if you want anything on the Q&A part about Dominion and about Dominion voting. So as one of my really senior colleagues and friends would say, like, if you want to define something in IT, you would just pretty much type that term and add Martin Fowler in Google, and it will all be set to you, like, just from that. So I admire Martin Fowler as I would say, even a scientist today, because he really did an excellent job of defining all the terms and phrases that we use today in computer science. As Martin Fowler says, so infrastructure as the code is the approach to defining computing and network infrastructure through source code that can be treated just like any other software system. Such code can be kept in source control to allow auditability and reproducible builds, subject to testing practices and the full discipline of continuous delivery. It's an approach that's been used over the last decade to deal with growing cloud computing platforms and will become a dominant way of handling computing infrastructure in the next. I would say that it's already a dominant way. I think that today I cannot imagine a company having presence in cloud without utilizing any form of infrastructure as a code. And I would say that pretty much I think that we are never going back to manual way of doing things, both in the cloud or the data center or any other way in IT when it comes to infrastructure. So how the story about the infrastructure as a code starts, I would say it starts with the tale of two teams. So this is something that I experienced also very late ago, because when I worked, for example, for Smith Microsoft, we had this story. So even though everyone says infrastructure as a code comes together with the rise of DevOps, and that's true, what really was happening, I would say 10 years ago. So 10 years ago, I was working for Smith Microsoft, and we had the development team in Belgrade, and we had the ops team, which was pretty much only me and no one else. And developers would write the software and the ops would handle all the rest, meaning that if we want to deploy an application, we would need to provision the server or check in our inventory if we have enough resources to put the application on the present server. We would need to deploy the database. We would need to provision the users. We would need to set up, of course, the operating system and all the security and patching policies in place. And we would, of course, from the ops side, need to support developers in order to make their releases. And imagine that, for example, you have 5 or 6 different development teams and only one ops guy that needs to support these 6 teams in pretty much manual way from the beginning. So lots of manual work, of course, meaning that you have a slow releases. For example, if I'm deploying an application today and I need to deploy a database and to provision users and to set up operating system and everything, pretty much I won't be able to deploy some other software until tomorrow or 2 days before, which means that people are creating tickets for the ops team is doing one by one. Then in case of failure, they need to go back. And it was a really slow process. And of course, a process that will lead to lots of errors. So after some time, when you're supporting 5, 10, dozens, hundreds of applications, you would go into something called configuration drift, meaning that you would have a lot of servers that should kind of act the same and have the same purpose, but in the end, they're not. So for example, on one of those servers, maybe you try to update a specific package. On other, maybe you just tweak the configuration a bit to use a different certificate or different folders for serving the application. On some third server, you maybe try to enable some security feature like SE Linux or tweak the firewall. So pretty much with a lot of manual work, you would end up in a configuration drift where for each of the next step or each of the next of the deployment part, you would need pretty much to connect to that server and check what's happening and why the configuration drift is there. Also, what always happens with developers in that time was that you would just get, like an answer from developers saying it works on my machine. But in those times, before Docker especially, like the local setup would differ quite a lot from the setup that would use in development, testing, or production environment. For example, developers would be using one version of Linux or maybe developing on Windows, and production would be completely on some bare metal Linux with reduced packages that were built compiling from, with make and some other processes. So it was quite, a lot of times it was quite hard, to reproduce the problem and really make it like that deployment to go seamlessly without any issues. So this tale of two teams, like putting the ops and dev development teams together pretty much was what made DevOps. And I would say the sentence that I found online a couple of years ago about DevOps was, I think the main goal is, the goal of DevOps is to make software development vastly more efficient. So what are, when we say like infrastructure as a code, so you write and execute code to define, deploy, update, and also in the end destroy your infrastructure. And that means in practice that you will automate the creation of your infrastructure, no matter if you're using cloud, you're using specific hypervisor, or if you're using bare metal servers. So infrastructure as a code should support, in theory at least, any platform where you are deploying your code. But also based on the like where are you deploying it and how you're deploying it, we can pretty much narrow down 5 different categories of infrastructure as a code. The first one, and the one that probably we all know, I would say, from on this webinar, is ad hoc scripts. So no matter if you're using using Bash, PowerShell, Python, any scripting languages, any general purpose software development language, you pretty much made a shell script or any kind of script at some point. And as you know, so scripts are really helpful. We use it every day, but as we know, scripts are really hard to manage, especially in software version control and when multiple peoples are developing those scripts. And the problem with scripts are they're not idempotent, which means that, for example, if you have a backup script that will just back up the last 30 files, if you run that script 3 times, it will take not 30 files, it will take 90 files from your file share. Also, if you're making a script and the script should create a folder, the next time you create the script, and the script will need to know if the folder was created or not, and you will need to do some manual checks, which means in the end the scripts become too complex and too hard to maintain. And also you really need to find a unique way on how to run those scripts, because also multiple people running the same script at the same time is not really good. The next type of infrastructure as a code, and I would say the natural upgrade to ad hoc scripts, are configuration management tools, which are such as Ansible, Puppet, Chef, and StoleStack. Usually, so with these kind of tools, you can pretty much do everything the script cannot do. So they are idempotent. These tools know how to check if a folder exists, if the backup script was already run, if the package was installed or not. But usually these tools are used for managing and updating infrastructure and not defining it. And of course, like you can see in documentation of Ansible or StoleStack, Puppet, or Chef, that they can work, for example, on AWS or GCP or Azure to create instances, but these tools have their inefficiencies, and pretty much they are just used when you already have a system where you want to manage and update applications on it. Third part is the server templating tools. So Docker, of course, is the most well-known, and I think that pretty much we are all using it today if you're in the field of software development. The others are Packer and Vagrant, and what is the purpose of these tools? They will make an image with all the settings, applications, features, whatever you want, but these tools really cannot be used by themselves to deploy these images. You need to use some other tools. That's where the orchestration tools comes in, and the fourth type, which is of course the most well-known, is probably Kubernetes, but some people still use Docker Swarm, Mesos, AWS ECS, or if you are in data centers, that's VMware vSphere. And as we all know that who are working with the Kubernetes, it's all about YAML today with the orchestration tools. But these tools come in together with the server templating tools, meaning that on Kubernetes, you will deploy Docker images that you build, and then that's how you will get the entire picture. So that's why they come together. The fifth, and I would say maybe the most important ones today, are the provisioning tools. And pretty much, even though I put here also AWS CloudFormation, OpenStack Heat, Terraform is the one leading this entire space. And these tools are pretty much what you will be using to set up your entire cloud environment in AWS, in Azure, in GCP. But also what is important is that Terraform has today providers for Kubernetes. They also have providers from VMware. They also can work on some, let's say, less popular or not so well-known providers like Alibaba Cloud or Hetzner for if you're purchasing bare metal servers. So Terraform is pretty much growing, and it's supporting more and more platforms as we speak. Now let's see how it works in practice. So just let me go from here. Okay, so I would assume that I used AWS for this small demo. So I would assume that most people on this call have experience with AWS, but even if you don't have, it's really not a problem. We will do a simple task of creating a manual instance on AWS. So here, if we go to instances, we will just select to create an instance. So nothing, this example won't be anything fancy. So we will just create one Amazon Linux instance and we will deploy it with completely default options. So we will take the default instance type, which is T2 micro. For those that are working in the AWS, the T generation is the one doing for, like, I would say, general purpose use. And so if you would like to create a VM for dev and test purposes, you will probably go for something like T2 micro to have the smallest instance. When it comes to all of these settings, we will keep them default, but just to mention here that we will use the default network with one of the default subnets. We will enable the public IP address. And these other options about scaling, hibernation, protection against accidental termination, or detailed monitoring, we really don't need for the purpose of this, but these are the things that probably you will template with your infrastructure as a code. For storage, we will keep as default. We don't need anything more fancy than this. And for tag, we will just name our instance. So we will put the name and we will say that this is test manual, as we are creating this instance manually. And for security group, we will just select the default security group and we will continue and launch this instance. So we have here a test key, even though we won't be connecting to the instance. But these are the steps that are required for creating an instance on AWS. And as you can see, as our instance is now being created, this is something that you cannot really skip. So if you come to AWS Web Console, you will need to go through all of these steps in order to create your instance. And now, as you can see, our instance is slowly provisioning. But as you can see, there are 5 or 6 different clicks, even if you want to use all the default options. And there is no skipping. So meaning that every time you want to create an instance, manually you would need to go through all of these steps. Of course, there are different actions on how you can clone or provision your instances with the other tools, but this would be the default way that if you go to the AWS website, you check the documentation, it will have all the similar steps. Now let's see how to do this in Terraform. So I have it prepared here. So in order to have the Terraform to work, you first need a file which is called provider. And in here, provider, we are saying which region we want to use AWS in. And this profile is tied to the credentials you need to supply. So AWS, who uses what they call as access key and secret access key, which is one pair of keys, which you will provision on your AWS account and you will configure in your profile. So here we're telling this provider to use this profile with these keys and this region. And besides that, of course, we need to somehow via code define the virtual machine or the instance that we want to create. So the other file, which we are using in this case for this EC2 instance is this. So what is required by Terraform is that you need to put the image, which we picked. If you remember, in the first step, we choose to use Amazon Linux. So this is the AWS ID of the image. And we need the instance types. So for example, we use T2 micro there, and we will use T2 micro here as well. So this was my typo from some previous example. And we also are going to do the tag. The same way that we manually tagged, we also want to create this, that this is called Terraform, test Terraform. So once you have these all 2 files set up, in this demo, we have the command line. First, you need to initialize this folder to be used with Terraform. And that's used with command terraform init. And this command will check our files, provider file, and will download the required Terraform providers in order for use this with AWS. Once you see this message, when the Terraform has been successfully initialized, that means that this folder can be used with Terraform and AWS provider to provide with the AWS resources. In order to check if our configuration is okay, we will use Terraform validate, but this is a really simple configuration, so there shouldn't be any issues. And as we see that this is the valid configuration, and the last step would be to really apply it. So the command is Terraform apply, and now the Terraform will check our configuration and give us the prompt if we want to apply this. So as you can see here, and I will a little bit expand this, all the things that we had in the options, Terraform will, okay, my screen is freezing. Okay, I'm back. As you can see, all the options that we have here and that we just skipped because there will be no use as default, they're all here. Terraform just is saying like, I will know the exact value after the apply because I'm using this from my default set of options. So the same way as the AWS is presenting you with the default options, Terraform is reading these options from the AWS API and also is filling these fields up for you. So as we can see, the things that are important for us here is we have the image, we have the instance type, and in the end, what we want to do. So Terraform says like, if you want to apply these changes, I'll just press yes. So we now do the yes part, and the Terraform is creating the instance for us. As this usually takes, a minute or two until this is done. So I think it takes like 30 or 40 seconds until the API calls are finished. But as we can see, and if we go back here, the instance is already provisioning for us. So we have two instances, the one that we created in 5 or 6 different manual steps, and the one that we pretty much created, the one that we created with only 2 configuration lines. So as we can see now, the Terraform is saying to us, I've applied the changes, I have what you wanted me to do. And as we can go back here and see, we have our other test Terraform instance running. So you can see that, of course, I mean, this is the instance that we created just for the demo. So this is the instance with default networking, with default security options, with the default key, default disk space. So a lot of things that probably you wouldn't use in your production. But I would say it's quite easier that you can do everything from this in only 2 lines and not needing to click 5 or 6 times. Also, if we want to destroy this instance, so let's say that we don't like it anymore, we can just do Terraform destroy. So if you put the Terraform destroy command and you're not supplying which specific resource you want to destroy, Terraform will check its entire state and it will delete everything. So here we only have the instance in the state, but as we can see now, it's the same instance that we provisioned. So we will put yes, and Terraform will now for us destroy this instance. And if we go back to the browser, we can see that Terraform is already, okay, so my session logged out. Let's just make a second. Okay. Yeah, as you can see, we have one instance that is running because the Terraform already started to destroy and it's already terminated other instance. So the way of manipulating with Terraform is pretty much easy. You have just a couple of commands. It's init to initialize, validate to check your code, apply and plan to see your changes and apply them, and destroy to destroy them. So it's just using a command line with just a couple of commands, but they're really powerful and they can do pretty much whatever you want. Also, what is important is that if we want to recreate this instance, we can again do Terraform apply, and Terraform will again lead the configuration files and it will ask to recreate the instance. Of course, what is important is that this is not the same instance that we destroyed. It's using the same image, but it will be created as a completely new instance with a different ID, just with the same name. Meaning that, for example, if we would create an instance and then go SSH to it, put like web server files in it, configure it, and then we do Terraform destroy and then do Terraform apply, unfortunately data inside that instance would be lost. So this is something that you really need to take care about in the configuration, in the infrastructure as a code setup, to really know what's happening with your data and what's happening with the resources you provision, because you cannot just easily destroy and apply things as ever you want and just hope that your data will be here. But we will talk about that in a little bit. Okay, so returning now to the presentation. So what are the best practices? The first thing is that always organize your code. So no matter how many AWS accounts you have, even if it's one account and everything is that one account, always organize your code. So use folders, use multiple repos as you can, do a prefix on your files. For example, if you have a database that is in production, do something like prod minus db and stage minus db. Always try to make your code to distinguish between the different environments, different resources. Try to group code in the files that are per resource. For example, if you're doing files for security group, for the firewall, do one file for security groups, one for instances, third for databases, fourth for load balancers, so on. So be sure to organize your file. Don't just blindly put everything in one file, because that's really prone to errors and it will create you problems as you go forward. Also, what's important is document your processes and change controls. So know how to do changes, know who is in charge of like doing the work. Use Jira, use Confluence, use any kind of tools that you use in modern software development in order to organize your process. Because if you don't know who is applying the changes and when, and with any type of infrastructure as a code, not just Terraform, but also Ansible, ad hoc scripts, Packer images, if you don't anyway version control, and if you don't in any way document that, you will quickly also have a configuration drift, even though maybe everything is in place. And as I said before, and I will need to emphasize again, version everything as much as you can, even the Terraform state, even the Ansible files, whatever you can, just save it as much as you can. The second thing is that make small, easily controllable changes. If you're implementing an entire application stack where you need to deploy instance, where you need to deploy a database, when you need to deploy security groups, load balancers, SSL certificates, try to do and break that into small tasks and do one small task per each and do small controllable changes. Because if you need to roll back, if you make some errors, it will be way easier if you only need to roll back security groups than if you need to roll back like 5 different or more resources at the same time. As well, always plan ahead and always test. This is also important in software development, but I would emphasize that this is even more important when you are working with infrastructure, because at most times infrastructure, if you lose it or you destroy it, it's not irreversible. And as we saw with this instance, it will just not create the same instance that you were using. So in the beginning, when you plan, think about future environments. Maybe at the moment you're only starting with dev and stage or dev and prod, but maybe in the future you will have a QA environment, stage environment, 2 production environments. So think about networking, think about security, think about if those environments will connect to each other with some peering of networks. Think about going multi-cloud. This is something that happened to us in Redbox. We started with AWS. We went to GCP. We had to redo our entire infrastructure on how we think about multi-cloud. Think about changing provider as well. As we can see from the examples of like that's happening in the world, companies do change cloud providers. Maybe they go from cloud to the on-premise, maybe they go from on-premise to cloud. So think about what will happen with all of your infrastructure if you go back to the data center. For example, that's what happened to Dropbox. Dropbox was an AWS, they went back to the data center. So if they did everything in Terraform for AWS, that's really completely not usable anymore in the on-premise environment. Also, implement test tools. In case of Terraform, there is a tool like TerraTest. There is also a way to achieve, like accept tests and unit tests with Terraform. You can speak with your QA department. Think about how you will also implement all kinds of tests into the infrastructure. And as well, what is also important, keep services always available. So always when you're using some infrastructure as a code, think how that tool, that specific tool, either it's a Terraform, an Ansible, or SaltStack, or even your scripts, how that tool can utilize, like things to make services highly available. If you're putting another service with, for example, Terraform, and that service is requiring first to destroy the old resource before provisioning a new one, you maybe will have a really big downtime. So think about using blue-green deployments, built-in cloud high availability, and of course, carefully read the output of infrastructure as a code tools. So remember that when you do Terraform destroy, see what the actual output will destroy. If you forget a resource, if you mistype a resource, you can destroy like your entire cloud environment in one click or one command. What are the benefits? So the benefits, I would say, as someone working in DevOps, are quite obvious. Like you're more comfortable writing code that you're all clicking on the web console. But other than that, there are many other benefits that different infrastructure as a code offers to us. The first, I would say, speed and safety. So if everything is automated, it's definitely faster, and we cannot argue about it. Of course, some people can say that if you need a lot of time to automate everything, maybe that one is losing the purpose of automation, but automation is faster, trust me. So automated processes are also more consistent and repeatable, meaning that if you need to deploy 5 different environments, and in each one of these environments you will have the similar network setup, you should automate it. Also, automation is giving us it's eliminating the need of appearing snowflake servers or configuration drift, which also a lot of happened before with the manual operations. Self-service environment. So you don't really need only your DevOps engineers to provision infrastructure. You can easily give your developers the power to do that by themselves. So developers can provision environment via CI/CD, or they can contribute to the internal code base of Terraform, Ansible, and so on. For example, in Redbox, with our pipeline, we can allow our developers to pretty much create the entire environment for themselves. They can deploy an entire Kubernetes servers via Helm charts, or via our Spinnaker and Formas tools. We can allow them to create EC2 instances, S3 deployment, security groups, IAM roles. So they can pretty much do everything they need from their own repo with just a couple of lines of code. So they don't need to come for us and say like, oh, can you please change my firewall or something like that. If they want to change a port, they go in, they change the port in their repo, they commit it, Spinnaker takes care of the rest, and everybody is happy. Also, with this, developers don't need to know all the bits and pieces of cloud. So what is, for example, Spinnaker doing under the hood? The developers pretty much don't need to know. They only need to know which port they need to let their application, for example, to be available on the internet. So they don't need that they need to go into the EC2, into the security group to click to enable TCP 443. They just would write port 443 and that's it. Voila, it works. Also, the benefit is documentation and version control. So your entire infrastructure will be in your Git repos, and you can use it the same way as you use your actual application code. And there are a lot of tools that even if you don't want to write the documentation, if you're lazy, that will generate documentation from your code base. For example, Terraform docs is a pretty neat utility that will take all your Terraform code and make documentation. So pretty much you don't need to do one really painful step in the process. And the last, and I would say the biggest benefit, is reusability. So Terraform has modules. If you need to create 5 times the networking or 5 times the same database instance, you can make one-time module and you can reuse that module in 5 different repos, which is a really saving time and effort and also eliminating all the errors that you can get. So how to pick the tools? So in theory, as if you would go, and this is the slide that I intentionally left only with one picture. So in theory, if you go to each one of these tools that I mentioned, the Terraform, the SaltStack, Ansible, each of these tools will say that they can do everything. So they can provision the infrastructure, they can install the application for you, they can modify the image, but in practice, it's not like that. So in practice, pretty much like if you want to provision your infrastructure, you will go to Terraform. If you want to create your images, you will rely on Docker, for Docker images, of course, or you will rely on Packer to create images that will be used for EC2 instances, vSphere VMs, and so on. And if you want to really apply the changes to those images, you will, for example, use Ansible. So in the end, unfortunately, you will be left with using at least 3 or 4 different infrastructure as code tools. And unfortunately, you will need to master all of them. So your engineers will really need to start from the bottom, reading the documentation, trying out things, starting from one repo, breaking the code base into multiple repos, use Ansible together with other tools, use Terraform. So in the end, it's not one size fits all. It probably will never be. And even though it starts easy and these examples that I showed you are small and it's a couple of lines, in the end, you really need to master it. And I think that for us in Gogo and Redbox, it took us a while. And I was lucky, of course, to join Gogo with already Joel Vassallo, which is here on the call, was already there. And the team already had a lot of things set up in Terraform and Ansible, and it was a great learning opportunity, to come and see what the people have done in the past few years and see, from their, I wouldn't say mistakes, but how they tried and how they improved the processes, and it was really great. So starting from scratch can be really painful, but trust me, in the end, it will be all worthwhile. So in theory, don't trust all the guides on the internet. Don't trust only, the marketing pieces saying, yes, just use Terraform and all your problems will be fixed. Yes, Terraform can provision infrastructure for you. Terraform can even provision Kubernetes objects and pods and services. But in the end, I would assume that you would need Terraform for infrastructure and to write YAML for Kubernetes. But try it out for yourself. Of course, drop us a note here. We are Threadbox. We're probably more than happy to help you. But it's not that easy. It's a journey, but you will be more than satisfied in the end. So horror stories. So yes, as I said, my manager is here, so no horror stories. Everything is perfect with us. But all jokes aside, I want to say that I really was lucky to come to a great team, and that really there wasn't really, let's say, some dangerous situations. But, I really do know some, stories from my background where some things would go wrong with scripts, or some things would, for example, go wrong with SaltStack or Ansible. So it happened to me once time, especially when I was, let's say, working for Dominion Voting. We were in Canada. We were preparing some elections, and I was doing a network script, and I applied the wrong configuration to the Cisco router. So what I did is that I cut off the office from the data center. So I needed to go to the data center. So that was like, I don't know, a ride with the metro for like 45 minutes. So I had to go to the data center with my laptop to connect the cable, and again to undo one line in order to connect the office back. So it wasn't anything serious, but it's not that pleasant to go to travel for 2 hours in order to undo one wrong configuration line. So luckily it was a situation that they didn't kill off the networking in the production. So the entire online votings was continuing and it was all okay. But the stupid mistake that I did because I wasn't paying attention cost me more than 2 hours, and of course, stress and everything that comes together. So these things happen, unfortunately. We all make mistakes, and the same way you will make, as a software developer, the mistake in your code, the same way you will do a mistake in your infrastructure as code. So you can do scary things, but as I said, like, first break your environment, try and like the environments that you can break, like test and stage. Be careful when you go to the production. Use CI/CD processes with approval when you deploy something in the production. That's what we use in Redbox, meaning that the code that I do, someone else from my team needs to improve to see if like it's really good and maybe there's some errors. You use all kind of testing that you can, like built-in tools, make your own scripts to test your configuration, apply the configuration to a completely empty server, empty environment. So do a lot of testing before you really apply, just to be sure. Of course, in some of these, I would say, cases, it would be easier to make a manual change, but manual changes are not audited. Manual changes are not, like tracked anywhere. And usually I would say as your business grows, no matter what is the purpose of your business, someone will at some point require you to show your work and to audit what you did in the infrastructure and what are the changes you made. So even though it's painful and even though you're going to make some mistakes, it's the right way to go. So this was it, and I was pretty much on time, which is good. So I would leave now this part for Q&A. I will stop my screen and sharing so I can read your questions.
Well done, Petar. 45 minutes. This was express. Thank you again. If anyone has questions, you can type in a chat box. You can type in Q&A option at the bottom of the screen, or you can just maybe raise a hand so we can turn your audio on so you can ask live better, or your video also. Oh, there is one question. Allowed to talk. Hi, Fabio.
Hello. Hi, do you hear me?
Hi, Fabio.
Yes.
Hello. I have a question. So if you use Terraform to deploy your infrastructure within Terraform, how basically how do you separate the infrastructure and the actual images container that you're gonna deploy on said infrastructure? I think for the example you made, it's very clear that they're just separated, but I think thinking, for example, with the AWS Lambdas, I think it's a bit less intuitive how you would separate the definition of the Lambda and what code you actually want to run on the Lambda.
Exactly. So you're completely right. So for example, Lambdas we don't deploy via Terraform. Lambdas we deploy via CI/CD. So we use Spinnaker, and Spinnaker along with Jenkins is building the Lambdas. So with Jenkins we build the Lambda into a zip file, and then we deploy it via Spinnaker. So Spinnaker will take care of the deployment process. So it works for us. But also if you want to really rely on one tool, you can also do it in Terraform. But in Terraform, you would need to specify, for example, the S3 bucket and the name of the Lambda. So then you would maybe need to change or to increment that file path to the Lambda in order to do the redeployment. But I would say for things like images, for things like Lambdas or something that is, I would say, that comes from your code that you need to build and then deploy, I would say it's better to rely on the CD tools than it is to the Terraform. And in my opinion, Terraform is best used to really deploy infrastructure, to really deploy the VPC, the IAM roles for Lambda, DynamoDB tables, anything that you need security groups, but then the actual Lambda, which you will build, package, and then deploy, better to use the CD tools.
Awesome. Thank you very much.
No problem.
Thank you, Fabio. Milica is asking, as a beginner at DevOps, can you give me advice on whether it is better to dedicate myself first to learning Bash scripting, Ansible, or other tools, and gain experience in cloud computing through working in a company?
Yes, definitely. I would say don't start with Terraform or Ansible. So start first with Linux and Bash, then slowly move your way towards, like something like Ansible to automate the things that you do. And while you're doing that, try to practice everything in the cloud. So try, for example, to use Linux inside the instance on AWS, and check how the cloud networking work, how the cloud security work. And once you pretty much nailed it, for example, that you can set up an instance in AWS, put a web server on it, make a script, that it will automatically deploy a web server with your code base, with security, with firewall rules, then try to do all of that in Terraform. So Terraform is, I would say, not the last step, but one of the last steps in the DevOps journey. And you really need to understand, like what is your operating system, what is the application you're deploying, and also how your cloud infrastructure works. So if you don't have like a solid foundation on AWS, Azure, or GCP on how things are working and what are the building blocks of that cloud, you also won't have, like that success in Terraform. So start from the beginning, and then later on, you just start to use Terraform when you really need it.
Okay, thank you. Joel asks, you mentioned that the developer won't have to go to opt for a change in firewall rules anymore, but that he would or could do it himself. Where would you draw the line between what knowledge about EAC a developer needs to have and where someone with a more specific knowledge is needed?
Well, I would say that the knowledge between, or where is the separation, I would say that, in my opinion, and this is just my two cents, and it doesn't really need to reflect the opinion of Redbox or anyone in InterVenture, is that I would say the developer who is deploying its code needs to know what he or she wants to deploy and where to deploy. Meaning that if you are building a static website with NPM, the developer needs to know that in the end, the output of his deployment are static web files, and that those files would need to be copied, for example, to an S3 bucket or the web server or something where it's deployed. So I wouldn't say that the developer needs to know how to create a S3 bucket in Terraform or how to deploy an instance with the web server, but the developer needs to know like what is the output and what he or she wants to deploy. And the DevOps engineer comes there to help. So for example, if you're doing a backend service, I would say that the developer needs to know that the backend service needs to be available on some port. The developer needs to know like how to create some sample Docker container and what is required to run that Docker container. For example, maybe you have environment variable to connect to the database, and one of these environment variable are the password, which is a secret. So the developers should know like how in that work, or at least say like, listen, this is my Docker container. These are environment variables I need. I run it like this on my local machine. How do I run it in Kubernetes and what's needed? And then, of course, working with the DevOps engineer, other things would come in mind. I'm not, let's say, against or for to enforce some things on people. So I would say the developers that they want to know more, I would encourage them, for example, to use Helm charts for Kubernetes deployment. But if someone of them doesn't want to do it, you can pretty much work with them to create a template and to, like make their life easier. So definitely there is no need to write Terraform code, but I would say I'm not against for them to know basic AWS services, how they work, what's required there from network connectivity or like making it available behind HTTPS and things like that. So, and vice versa, just, to kind of try to round up the question, I would also say that the DevOps engineer should know if his developers, like if he's working with front-end developers, the DevOps should know at least, how to build NPM and to know a little bit what is the purpose of package JSON and how NPM modules work. And the same goes, for example, if you're deploying, I don't know, Java or with Maven and Gradle and things like that. So we need to know a little bit about from the developers' work, but the developers also know a little bit about ops work as well, so we can make a synergy together.
Mike said AWS Free Tier provides a good start point to play around with understanding working with Linux and networking permissions, their limitations, but to get some exposure to cloud would be a place to grow. I would guess this is information.
Yeah, Mike is my colleague from Redbox, and Mike is continuing on the question from Milica. Yes, AWS offers a free tier. You have a lot of services for free. Also, console will give you like a small icon to say this is free. So you can, for example, for a year, you can run your one Linux instance, one database, one load balancer, one S3 bucket with like up to 5 gigabytes of space. So you really can run your small AWS environment for test and pretty much don't spend any money on it.
Thank you, Mike. Thank you, Petar. Any more questions? You can raise hand if you want to be heard and seen. Okay, I think you pretty much explained everything, Petar. Well done. Oh, we have one. Let me see, where is it? Oh, Milica. Hi, Milica. You can talk now if you like.
Do you hear me now?
Yes.
Yes.
Okay, thank you. I couldn't find the option. I just wanted to ask, can anyone provide me a link to that tier to try that things with Amazon Web Services?
Sure. Just a second. So follow this one. Let me just go back to the Zoom chat.
Just post to panelists and attendees, please.
Okay.
To both groups.
Oh yeah. So yes, my colleagues were fast to do so. So
and Marco and
this
Joa,
is the link.
Thank you, both of you. We have the question: what are the differences between Ansible and Terraform?
So in short, so Ansible is a configuration management tool, meaning that, for example, if you want to apply Ansible roles, and for example, you have an Ansible role that you install the web server and set up the certificate and some, let's say, static HTML pages. Besides that, you would need to provide a list of servers where you want to apply that role. So Ansible really needs, besides like what you want to do, you need to tell Ansible how to do it and on which servers to use this configuration. While on the other side, Terraform is used to pretty much create the infrastructure. So Ansible would need, like in essence, in many occasions, like to really say, like, I want this to be applied to these servers, where Terraform will deploy those servers from scratch. So they have some overlap in terms that, of course, that you can provide the user script and script what you want to be done in Terraform, and also Ansible can as well use some AWS APIs to create these instances. But usually, you know, like there is a clear separation between the tools that are provisioning stuff, like Terraform, CloudFormation, OpenStack Heat, and tools that are used to configure on already present instances like SaltStack, Ansible, Chef, Puppet, and so on. So the good thing about Ansible is that Ansible doesn't require any agent, so you can also run commands from your workstation, where, for example, if you compare it with SaltStack, on SaltStack you need to have a master server that is controlling the minion servers. So you need to have some kind of agent installed. But it's a really broad topic. So if you even go to Google now and say Terraform versus Ansible, you would find 5 different links with different explanations. So this also comes to the part when I was telling that in theory, everything works and they can really do similar things. But as you go on and as you try things, you will realize that some tools are better for some needs, you know, like, so, I mean, like, you can eat everything with a spoon, but of course it's easier to use fork when you know, like, you want to press something in the fork compared with a spoon.
Thank you. Joel posted some useful links in chat, so you can take a look for free service. Okay. We have a few more minutes, and Petar here who is willing to answer your questions. Ozan is saying thank you for a clean and comprehensive session. Okay, if that is everything, I would like to thank all of you. Awesome talk, Petar. I've truly enjoyed it. Informative, fun. It went like a charm. It did. I agree. Thank you, Petar, again. It was a pleasure listening to you. Thank you, everyone, for coming. You will get the link to video in your YouTube, in your inbox, and it will be posted on YouTube channel tomorrow. We will see you in different webinars that we are actually planning to make, maybe with Petar again in the future, who knows, or other colleagues in a DevOps subject. Enjoy your evening, and thank you all for coming, and we'll see you next month.
Thank you, guys. Bye. See ya.
Thank you. Bye.